Hello, Introduction to Java Programming. In this session, we will discuss about finding sum of array elements, finding the min and max of given array elements, and also searching and sorting of array. Let's begin. So in the previous session, we understood how to declare an array, how to initialize an array, how to create an array, and also how to read data to an array and how to write elements of an array to a monitor or any output device. Now let's actually begin from that particular point where we have left. And this is the program. If you see, we have an array declared whose name is ARR and which is actually taking 10 integers. So my array is getting created over here with 10 integer elements. So 10 into 4 bytes, so total 40 bytes is going to get allocated for this. Okay, and then I would like to populate my array. So I can actually give array elements to this particular ARR array, either by reading data through a scanner, or I can actually populate using the random number actually. So I'm generating a random number. How many times? Array dot length times. So array dot length is 10. So 10 times 10 random numbers are going to get created, which are actually between 1 to 100. Okay, this is how I can populate. Of course, we can actually populate by reading data from the scanner also. So that's the reason why I took actually scanner. I will actually show you this at the end actually. Now, so this is the program to these are the lines to actually print them. Okay, so let me compile and show you that it works actually. So array declaration and creation, then populating, and then printing. So this is what actually we have already seen. Let me actually see whether it is working or not. Yeah, now you can actually see 10 elements got generated and they got printed starting from 24 to this particular 80. Okay, so now the first thing I would like to tell is how to find the sum of the array elements. I want to find all the sum actually. So that's so simple actually. Whenever my array is getting populated, I will actually do the logic for sum actually. So finding summation, finding the average, finding min max, searching for an element, sorting the array element. So these are some of the algorithms which we can use actually on any collection. That means any group. So here array is actually kind of a group. We can actually do all that stuff. So here, while I am reading my array elements through random number uh, generation, what I can do is I can add that to my sum. So I will say sum plus equal to, I am using compound assignment, this particular array of I. Okay, what is this sum? What is this sum? Sum I have to declare somewhere here, right? So int sum equal to 0. Okay, and I have calculated the sum actually. Once sum is calculated, I can print it. Okay, so I just say system.out.println sum of array elements. Otherwise, I can say ARR, sum of ARR elements, and that is nothing but the sum. This is how we can actually find the sum. And if you know the sum, actually, average can be found. So straight away, I will actually print the average of ARR elements. So how to find the average? Well, if you know the sum, average is actually sum divided by uh, the size actually. How do you find the size? Array dot length. Okay, this is how we are actually going to get the average values. And later I'm printing all the values. Let's actually see this. Okay, so otherwise, what I do after printing the array elements, I will actually do this sum and average. Okay, so what I'm doing here, I'm printing sum and average. Let me actually go here, compile this again, and then run. Yeah, you can actually see for all these things, the sum is 580, 80 by 10 is 58. Okay, so next time, then 469 and this is 46. Actually, because this is integer division, so any decimal points, they are getting actually truncated. That's fine. So this is one algorithm that we can actually do. So populating the array, printing the array, finding sum and average, right? Yeah. So now let's actually find the min and max of this array. How to find the min and max? Okay, given array elements. So here there are good number of array elements. If you see here, what is the maximum element? So as of now, I can see something maximum is 71, right? And what is the minimum element? Somewhere 29 is here, then yeah, so I think 29 should be the minimum, right? In the same fashion, you can also generate, and you can actually see here, somewhere here the maximum I can see as 99. The minimum number we can actually see here is somewhere 38, 33 is there, right? So how to find the min and max? For that also we have an algorithm that is very simple. What we need to do is we have to assume we should have actually min and max as integers. So let's take int min, uh, which is equal to array of 0. So this is the logic actually. And int max, which is equal to array of 0. So what we do to find this is we assume the first element itself is a min or maximum. Okay, in a group. Okay, in a group here I have the group. I will assume this 47 itself is the min or maximum. Later what I do, I will actually compare this one with the next one. If the next one is the min, I will change the role actually. Now I will call 38 as the min. If the next one is the max, I will change the role. If uh, if that comparison fails actually, then I will continue with my min and max. So that means here my 47, I am assuming, let's say, max. Okay, so 47 compared with 38, still my 47 is max. I will not do anything actually. Now my 47 next actually compared with 78. So 78 is greater. Now I change the rules actually. I will say 78 is the max. Right now 78 with 39, still 78 is the max. Then 78 with 76, still 78 is the max. So far till it gets 89, uh, till 87, actually this one 78 is the max. When 87 comes, 87 will become max, and then 99 become max actually. So this is how we will figure out. The same is the case with the min also, right? So how to write actually the code? So for that you need to write one for loop, the same for loop like how I write over here. So let me actually take this. So for I equal to 0, I less than array dot length I plus plus. So this is my logic actually. So what I'm doing, I'm actually checking this array of I value. So I have to compare all the I values. If array of I value is less than whatever I'm assuming is the min. Okay, I'm assuming first one as the min actually. If something else is minimal than this, then I will change the rule actually. So what I say, min is array of I. Min is array of I. Otherwise, if it is not, this statement is not true, my min remains the same first one only. Otherwise, my min is getting updated. In the same fashion, I have to check for the max actually. The simple logic: if array of I greater than max, then I have to change the roles actually. So max is going to be array of I. That's it. So this we will continue in the loop actually. As long as the loop is there, we'll get continue. Once we are done, we just say system.out.println min equal to, okay, just we will say min equal to, or min colon, that is min, and then I will actually give some space over here. When I say here max equal to, yeah, max. So this is how we can actually print find min and max. So let me actually go over here, then compile this, compile successfully. And when I run, then you can actually see out of these 10 numbers generated, minimum is 18 and maximum is 86. Now we can actually see 18 is there. This is the min one, and somewhere here 86 is the maximum one. So let's try for one more. So now here the min is 28, here 28 is there, and maximum is 91 actually. Let me try once again. So then actually you can see 93 is the maximum, that is the first one, and somewhere 19 go to the minimum, right? So this is actually min max. Okay, so now once we do this, let's actually do for searching an element in an array. Search for an element in array. Okay, this is interesting actually. This is an interesting algorithm. Search for an element in an array. Okay, so what I do actually here, I will ask the user to enter an element to search. So that's why I took actually scanner as well. Okay, so what I do here, whether such algorithm is actually, so given array elements, whether the particular element is available or not. If it is available, we have to say this element is found at so and so place. If it is not available, we have to say the element is not found. Okay, so we have to say when it is found, and it is not found also, we have to say actually. Okay, so for that, what I do, I will ask the user initially, please enter an element to search. So by the time array elements are printed, so you can actually choose which element you want to search. So please enter the element to search. Okay, so this element I would like to take in some X actually. Okay, so how I take actually using scanner. So my scanner is actually scanner object is in over here. I'm using in dot next int. In dot next int. Okay, so now you can read the value, right? Now what is the logic? How to search actually? So very simple. See, for example, here I have these elements and I want to search. How do I search? Okay, for example, I want to search for 46. Now I will start from the beginning. I will say, are you 46? Are you 46? Are you 46? Somewhere 46 is matched and it is found. So when it is found, you just come out. You need not to stay over there. Use the break statement. Okay, so now this time I given 19. So I will start from the beginning. Are you 19? Are you 19? Are you 19? Yes, whenever 19 is matched, I will come out actually saying such element is found at so and so index. So that's the logic. So simple for loop actually. So let me take the same for loop over here, which we have written earlier. Yeah, this is the for loop for int I equal to 0, I less than array dot length, I plus plus, and here the logic actually. The logic goes like this. I need to search. Okay, so for that I am actually using a decision making statement. So what I'm saying is, if x equal to array of I, if x equal to array of I, so that means the x element I'm searching is actually matching with any of the elements. Okay, then what will I say? I just a print statement straight away saying that x, whatever the x element which we are actually checking for, I say x is found at index, x is found at index, and I will give the index value. What is the index value? That is I actually. That's it. Okay, and what I do actually here, I can actually break. So when it is found, I can come out. When it is found, I just come out. I need not to waste the time. But before coming out, what I do actually, I will set a flag actually. I will set a flag equal to true. Okay, this helps me. So this helps me if element is not found actually. Okay, it helps to determine if element is not found. Okay, so let me declare that flag actually initially. What is the flag? Boolean flag equal to, initially this is false. I didn't set the false. I didn't said it as a true actually. That means we are saying the flag is false. That means element is not found. But whenever I found the element, whenever I find the element, I am saying it is true. Okay, initially the flag value is false. If the element is available, I say it is true actually. Flag, I will actually assign true to this. Okay, then after coming out of the loop actually here, I will actually check based on this flag value. If flag is still false, If flag is still false. If flag is true, we are saying it is found and we are actually printing that element. If it is false, that means what? The flag was not set. That means what? Yeah, so this X is not found. Okay, that X is not found. So X is not found. Okay, this is how we can actually make things for the element not found. So that's why this flagging is required. Okay, so just search from first to the last. If it is found, just say found, and you can come out. But how do you say with whether element is if the element is not found? So something we should have actually. That's why when it is found, I am setting a flag. If it's not found, that means the flag value is original value, that is false. So the flag is still false. X is not found actually. So this is the search algorithm. Okay, so let me actually go and compile this Java C array demo.java. Compiled successfully. And when I say Java space array demo, now you can actually see these are the sum of the elements. This is the average of the elements. Min is 16, max is 16. And then please enter the element to search. So now I want to search 29 actually. So this 29 is actually at the index 9, right? So 29 is found at index 9. Now this time I am actually asking for some 25. 25 is also at index 9. And then here I am actually saying 7. 7 is found at index 6. Okay, if something is not found actually, so for example, I want to give 100 here. 100 is not there, right? So 100 is not found. Okay, one more. So here I am saying some 50, 50. So 50 is not found. So it's working actually. This is the search algorithm. Fine. And yeah, so last one actually. So I would like to tell about the sorting. So sorting, there are good number of algorithms available like bubble sort, selection sort, insertion sort, quick sort, mid sort, and so many good sorting algorithms are there. I'm not going to implement any sorting algorithms, but rather I would like to give one useful utility which is there in the util package. Okay, so here we have a class actually called in the util package, that is arrays. Java.arrays. Java.util.arrays actually. Okay, so this is the class, and this class has some useful utility functions. It has some useful utility functions, and there are certain methods like sort is there, methods like shuffle is there, reverse is there, binary search is there, okay, etc. Okay, so now what I want to do is just I want to make a search over here. So now sorting. Okay, so I just want to sort it actually. So sorting the array elements. How do I do? A simple way. I'm not doing any algorithm implementation. Rather, I'm using already available function. So I know there is arrays class. Arrays class I will use, and I call that static method. There are so many static methods like reverse is also there. Arrays dot sort, so it will get sorted. So sorted in ascending order. That is a natural sorting order. Whenever you sort, you will actually get natural sorting order. That is nothing but the ascending order actually. Okay, and after sorting, I just want to print. So we have already the lines to print actually. So this is how we print, right? Print the array, and just take this, and I can actually write over here. So printing the array, okay, after sorting. After sorting, not just sorting, you can actually reverse it also. Okay, you can shuffle it also. Just use the methods arrays dot shuffle, arrays dot reverse. These things actually is going to be done. Okay, so just let me write actually here. Short method is there, shuffle method is there, it will shuffle the elements. Reverse is there, so the array will get reversed actually. So these all are some utility methods you can directly apply here, and you can print the values. So now let me actually show over here. Yeah, compile. Oh, sorry. Arrays dot sort of what? I have to pass the array, right? So I am saying arrays dot sort. But what I want to sort, I need to pass the array. Yeah, I forgot to do that actually. I am passing the array now, and yeah. So now this will get compiled now properly. Yeah, compilation was done, and then when I run, so everything actually. So I am printing all the array elements, finding the sum, finding the average, finding the min max, and I am searching also. For example, I am asking for 91. 91 is found at 6, and this one is actually sorted array. After that, I am printing sorted array, right? Okay, if you want, you can I can actually write one more line here, sorted array. Sorted array. So now whatever we are seeing is actually getting sorted. Okay, let me actually run again. So enter the element to find. This time I am asking for 4. 4 is at index 7, and this is the sorted array. See, 4 comes first actually. 4, 9, 13, until so on. This one. So this is about some of the algorithms which we can actually use in a group, just like sum, average, min, max, sorting, searching, etc. Okay. Hope you have understood this. These algorithms which we can use on arrays. And here one last thing is I'm populating actually. I'm populating the array elements using the math actually, math.random. Okay. Otherwise, what actually also I can do is, instead of using this one, I can actually use this scanner also. I can actually use this scanner also. So let me add that and close this session actually. So I have already the scanner. So populating array. So what I do is I will ask the user, okay, to enter how many elements. Array dot enter how many elements. We have arr dot length, right? So those many elements. So we should always write variables actually. We should not hard code. We should not say enter 10 elements. We should array dot length. If the size is changed, everything will get changed. Right now, what I'm doing, I am making int size equal to only 5 only, because I have to give the values, right? I just give the 5 values. Okay, then it will become automatically array dot length, that is 5. If it is 20, then array dot length will become 20 actually. Fine. Yeah, so that's how we have to do it. And then I have to read the values. I have to read the values to my array. I have to read the arrays to my array actually. Array of I equal to, how to read actually, in dot next int. So all integers only, right? In dot next int I am using in my for loop. So that means what? So I have to provide 5 elements, and my for loop actually execute for 5 times. Each time it will take the elements which I have given and will add it to the array of I, array 0, 1, 2, 3, 4, 5. And at the same time, I am doing the summation also, right? So this is how I can actually taking array elements to the scanner. That's it. That's simple. It is actually. Okay, let me compile. Now it asks me when I run, please enter 5 elements. So now I am entering 23, 45, 67, 89, and 30, and 32. Right? So now I will have all these things. Some of the elements is 256, average is 51, minimum is 23, maximum is 89. I can actually search for 45. So 45 at index 1, and later I have the sorted array. So 22, 32, 45, 6, 7, 8, 9. Okay. That's it actually. So if you want to run one more, I can actually give. Now I am saying 1, 7, 4, 3, 1, 7, 5, 3, 4 actually. Now you can actually see all of them coming up, min and max. Search for some 9 which is not there. 9 is not there. The sorted array is 1, 3, 4, 5, 7. Right? That's it actually. So these are all the algorithms which usually we will actually work with any group. So hope you have understood. And in the next session, we will actually learn about arrays of arrays, which are nothing but n-dimensional arrays. Thank you.